Good morning. My name is Steve Lewis, and I'm the CEO and founder of Living Planet. It's my pleasure to be speaking to you today to discuss important trends and shifts in the evolution of the internet and its impact on our quality of life and how we'll live in urban environments in the future. And I hope to cover quite a lot of ground, principally around two principal market trends. First is how the internet is evolving from a content sharing platform to being able to sense, to learn, and to be able to act to improve our quality of life and improve our economic opportunities. The industrialization of the internet is a shift from simple content sharing and social media to becoming a reliable utility on which we begin to depend. It's probably the most profound shift in the computing industry that we've seen in 20 or 30 years, and since you'll have seen in the press many discussions around its potential implications. I won't bore you with all of them right now. Before we go forward, I want to look back a little bit and give some context just to how fast this industry segment is moving. In the top left-hand side of the slides, you'll see the Hubble telescope and some images that were produced over the last few years. The Hubble telescope was launched in 1994 and is used to look into our universe and beyond and try to understand what's going on in the vast complexity of space. It's basically a control platform with sensors, gathering data, principally light and other signals, and then transmitting that back to Earth, and then making minor adjustments to focus in the areas of interest. If we move beyond the Hubble telescope, we start to see other platforms being deployed into the rest of our planetary system. The image to the right is the Mars rover, that's Curiosity, that's currently moving around the planet and looking at both geological information as well as space environment. The next row, you'll see Google Maps, where we're looking at our own planet in fairly high detail. And then you start to see how we take other data from ground-based stations. In this particular case, we're looking at emissions in a city. In this case, it happens to be methane, and how we start to integrate that with that visual data. The bottom row is a very exciting area of science. We're moving from large objects to looking at very small objects and beginning to control them. From this case, using microbes to digest waste products. In this case, it happens to be Tetra Pak that you buy your milk and other products in, right through looking at geological or geophysical features below the ground up to multiple kilometers and looking at molecular structures. To the right, we're looking at the atomic bonds in a molecule of carbon monoxide. We're also beginning to move into a very interesting period where the internet can start to talk to biological structures. In this particular case, is some work from our advanced research team where we're actually programming microbes dynamically, telling them what to do, in this case, digesting waste and turning it into other useful materials. And as it does so, it starts to communicate back to us via amino acid chains that we can measure through the light frequencies of those amino acids. And so we effectively have machine communication to biological sources. Many of you are familiar with handheld devices. Most of you will have a smartphone or other type of device. These devices are now starting to incorporate other forms of sensing. For those of you who jog or use these applications for health, you'll be very familiar with these. However, these will become much more pervasive over the coming years. This particular device happens to be a contact lens. We call them hyper-wearable devices, something that you depend on every day, that is not embedded in your body but you wear. This particular device is looking at sugars being produced from your eye fluids to determine what your rate of insulin production is and to enhance vision. This next little device actually is produced and printed onto your skin when visiting the hospital using a lithographic process. It's using the heat of the skin to produce energy so that that device can communicate with a network, and it's starting to measure certain substances that come through your skin to determine what's going on within your physiology. When you look back across all of those elements, you see a world connected by a common network that is talking to both digital electronic devices and biology. And the volume of devices that talk to that network grows exponentially over the coming years. We're a software company, and I don't intend to go through the detail of exactly what we do today, but effectively we produce software that enables the internet to sense what's going on in its environment, take that data and learn from it, and then make intelligent decisions about what it acts upon, changing things in our physical world. Also, that data can then be provided to other forms of applications, and so we take, let's say, video information that on the one side may have something to do with your security, but also may be measuring your heartbeat. Second major trend over this last 10 or 15 years is man has become principally an urban species. And we move into cities for a number of different reasons. Principally economic, or for social development or social mobility, to improve our quality of life, our security, access to resources, to get a better education and healthcare. And over the last few years, we finally shifted to the majority of mankind now living in cities, and that trend is going to continue, with about 70 to 80% of the world population living in cities over the next 20 or 30 years. As a result, we have to accommodate many more people and their families, and so we're seeing both extensions and redevelopments of existing cities, and we're seeing new cities starting to emerge. The challenge we have is that the development of cities or the creation of the new spaces requires an immense amount of resource. And so we're starting to see software being used to change the way we design, the way we deliver, and the way we operate those new environments. This particular project is our development in Portugal called PlanIT Valley, which will be the center of major research around the world looking at urbanization and the application of technologies to improve quality of life. This particular site is Convida in Brazil. It's one of our strategic alliance partners. Convida is building mixed-use developments that are designed to improve well-being in all of its dimensions, not only health, but also how society functions, how we create economic opportunity. And these will be replicated in a number of states in the northern part of Brazil. Likewise, to support a city, you need to have logistics and supply infrastructures to be able to support those new environments. So let's talk a little bit about the shift that we've seen. If we look at microelectronics, we've seen microelectronics becoming commoditized, much higher quality, much more reliable technologies, mass-produced, with an immense amount of complexity at very low prices. We've been able to achieve that through the use of simulation technologies, design technologies, and then manufacturing processes that reduce the amount of resource we need to actually produce these particular products. In this particular case, we're using software to look at how we would deploy a city, how we would design a city, how we use the physical land and topography, how we match that to the movement of air, the movement of people, and how we place particular assets to make the city both efficient in terms of mobility and how people interact with the physical space. We're also using software to design every intimate aspect of buildings so that, one, we can design them to be more efficient in their use of resources. Secondly, that they support the human use of those buildings in more efficient ways. And thirdly, that we manufacture en masse the component parts that then are assembled extremely quickly. In this particular slide, you'll see some little circles between the floors which represent new forms of sensing and actuation, controlling the building and sensing what's going on in its environment. As a result, we see the convergence of this very rich technology with the urban environment. And a great analogy I find is what has happened with the smartphone market. And specifically, I'm going to choose that Apple iPhone here. The iPhone really is a piece of hardware which has a number of sensors in it, a number of actuators, an operating system, and applications. Those applications vary dramatically depending on what somebody's interest is. And so whether it be for sport or whether it be for news, whether it be for other forms of digital content or to manage my health, a combination of the factors of the phone and the computing infrastructure providing those services. If we use the same analogy with city, and we look at the scale of some of these developments and redevelopments. Whereas in a cell phone, you have 5 or 6 or 7 sensors. In a city, you can have 10 or 12,000 different types of sensors, but they're deployed at a massive scale. In some cases, will be billions. When one thinks about then the diversity of the data sources that I have and the things that I can control, plainly then we see a diversification in the applications that support our lives, whether it be at work, whether it be in education, whether in health, or whether it be at home. Also, those applications interact with the infrastructure. And so in addition to new systems for energy production, distribution, storage, water and waste treatment, mobility, transportation, logistics, and a whole range of other heavy infrastructures, we will see a diversification in the devices that access those infrastructures, the analytics of the data that comes from those infrastructures, and the types of applications we'll deploy, creating what effectively becomes an urban app store. This particular slide, we're showing a few examples. At the top left, we're showing a healthcare example where we're taking data from a patient's sensor looking at heartbeat. To the right, we're actually exposing data from a physical building that has been designed, where we're showing its performance against certain sets of characteristics. But it's not only complex applications. Many of us use Microsoft Office. If I just want to extract data or produce a report, Microsoft Office can work against those infrastructures to extract that data and produce the reports that we want to be able to show to other folk. Also, we'll see other forms of specialized applications that are reaching deeply into the infrastructure and the operation. This is all data that is coming in real time, measured by little sensors deployed in everything, and also talking to the actuation systems like pumps and heating units and so on, taking that data and then presenting it back in ways that we can make sense of. This is a consumer application built by Philips called Vital Signs. Vital Signs is an application that turns on the camera on your phone, takes a very high resolution video stream from your face, and then starts looking at, one, the movement of your face to determine when you're breathing, and secondly, every time you beat, your capillaries pump blood, therefore they get a little redder and your face starts to change color. You can't see it, but the camera can, and so it's correlating these two factors to measure your breathing and to measure your heart rate extremely accurately without any form of invasive or intrusive device. Here we're looking at street furniture. This happens to be a smart lamppost. We're into that lamppost talking to the network, or beyond its lighting functions, other forms of sensing, looking at the environment, looking at security, looking at communication, and other applications. Automotive, our ability to move around in mobility systems is another area of huge innovation, where we're looking at a very fast-moving pieces of information, correlating them, and looking at things like the powertrain, braking systems, human systems, and others. We will see this area expand broadly in automotive over the coming years as those vehicles talk to the city. We're also seeing these technologies move into critical healthcare applications. This is an example actually with McLaren deployed at Birmingham Children's Hospital, where both air ambulances, regular ambulances, and the ICU, the intensive care unit, is taking data directly from the physiology of the children in real time, monitoring them at a nanosecond rates, and figuring out what the environment does to the child and how to improve that, how drugs are being effective and how to change that and adjust it to the unique changes and diversification in people's physiology. Another thing that we will start to see over the next year or two is new materials coming into the places that we build and deploy. In this particular example, on the left-hand side, it's a holographic projection from a laptop cover. On the right-hand side, it's windows that, with sensing, can detect that the heat is changing outside, light is changing outside, and we can dim the glass by applying an electrical charge to it. Here somebody's woken up in the morning and we're starting to bring the data that they need to start their day into the context of where they are. So whether it be a bathroom mirror or other surfaces around the home, whether they're tables or walls, their floors, their refrigerator surfaces. And here we move into sort of our work day, whether it be in a hotel and understanding what's going on in local traffic patterns, and that data being sensed from that local environment, or bringing other forms of data into the now, whether it be mobile communications or what's happening in my physical environment. We're all fans of social media, and many of us have many social media accounts. Now, this is an example of my Twitter account where I've subscribed to our urban operating system for certain pieces of data. I want to know when somebody comes into the home, when they leave, is my security okay, and what's happening with my dog. And in this particular case, based on the things that I've subscribed to, I'm getting information in real time that's of interest to me in the places that I most regularly go or want to monitor or interact with other parts of my life. This last example really is the convergence of a number of those pieces. So let's recap for a moment. We're seeing an immense shift where the internet can begin to sense, to learn, to act, and support in a fundamental way the things that matter to us in our lives. Secondly, we're moving into urban environments, and those urban environments are becoming enriched by that deeper level of technology. But we need to bring some process and order to the things that we do, whether it be in government services or the way we go about our lives. And so an important shift now is how we go bring methods to go define how we want to interact with our life, define that process, have it track that data, act on that data, and then perform the various tasks that we're interested in having in supporting our general day-to-day existence. Anyway, most importantly for me, the shift that is coming will have vast economic and social development consequences. The world will be defined not by individual countries, by the development and the economic and social stability of the cities within each one of those. And so this shift is creating both opportunity for employment, for social integration, for social inclusion, and is being driven by a very important wave of innovation, both in the technology industry, social sciences, and biology. Thank you for your time.